This video is part of a series of videos that I'm making to help people become better Linux users, in particular if they're working for the command line. Now, when you open a terminal, like I have here, a couple of terminal windows, you may think that you're interacting with the operating system directly, but really you're interacting with a program called a shell. And the shell is a program then running on the operating system. I'm going to talk in particular about the bash shell because that's the one I use, and it is the default for many distributions of Linux. And until a few years ago, it was also the default for Mac OS, but now I think they use what's called the Z shell. But some of what I'm talking about here will apply to Z shell as well. If we look, this web page here, here's a comparison of 5 shells. There's actually a lot more. Like bash actually stands for born again shell, and it's a replacement for the bourne shell. TCSH is a replacement for C shell, so this is the C shell. And if we look at some of these examples they give you to show how they compare, at least for these specific examples, you can see a lot of these are the same. Like LS, echoing values, some of these things with pipes. Scroll down, some of these other things, how you escape certain things. There will be some differences or else we wouldn't have different shells. But you can see there's quite a bit of overlap. So that's why I'm saying even if you don't use bash, some of what I'm discussing may apply to your particular shell, either exactly or the concept may apply. You just have to find the specifics like this versus this. Fish is the newest of these, I think. And so I would expect there would be more differences between bash and fish than bash and, say, corn shell. Okay, that's what that stands for. So first, how do you know what shell you're using? I can check the what's called environmental variable. Environment variable. So I'm going to type echo, $capital shell, and that says I'm using bash. Okay. Now bash is controlled by some configuration files. You really don't have to necessarily use much in the way of configuration files, but there's certain ways I want to configure my environment for my use. I want to control my path. That is where I find things. I may want to create what are called aliases, which are shorthands for doing certain things that I do over and over again. So let's look at these files, or at least my particular ones. And we'll need to get to my home directory, which is actually here, to get to these. Or I could have just got to it via a longer path. So notice the first thing it does is it attempts to source, that is run.bashrc. So we're going to talk later when I get down here to programming that shells do have their own programming language, or at least some of them do. And so this is a conditional as it's written in the bash shell. So this says if this file exists, then attempt to source it. If it didn't exist here, you wouldn't want to attempt to run it. So the dot and then caret means my home directory /.bashrc. It says if this file exists in my home directory, then run it. That's what the dot is. And this is the way I end the conditional. Then you can see that it's updating my path. So this is the environmental variable path. And so this says create the new path by taking the old path and then adding this after it. And then right here, I'm creating a new path by taking this and adding the old path to it. Because order matters. If I type something like, say, Python, I want to run Python. If I type which Python, it's going to search my path to try to find Python. And the first one it finds is the one it's going to use if I just type Python. And so I might install a version of Python in my home directory that I want to use instead of the one that's on the system. And so if I just want to be able to type Python like this and have it be the one that I use in my home directory, well then it needs to occur before the system version of my path. And I can look at my path and there may be some redundancy here because things get sourced multiple times. You can see it's doing a search here first, then it's doing a search here, and the last thing it's searching is this bin directory. So I have a bunch of different bin directories, right? That's where you have binaries. So you can see here I have like op local bin, op local sbin. I'll have user local bin. I have the one that's in my home directory. I have one that's in a Dropbox directory, which is the one here under drop bin, things like that. And so if it can't find something here, it's going to look in the next directory. If it can't find it there, it looks in the next location. If it can't find it there, it looks in the next location, and so forth. Some of these things get added by programs when I install the program. So this is something I added a long time ago. And in fact, at this point, I don't even remember what it does. And then I like to add comments. Things that start with the pound sign are comments. And I add comments to remember when I did something and what the change was. So that way I can undo it if I need to. And there's probably not a lot else that's here. You see it's adding more things to my path. Some of these may not even be valid anymore because you can see some of these are 10 years old or longer. Let's look at bash RC. So this is the one that came. I use OpenSUSE for my distribution of Linux. So this is the basic one it came with, and I add things to it over time. Here it's checking to see if I have an aliases file. If so, it's going to source it. I personally don't use one in my local directory. Instead, I put one in my Dropbox. Drop here is my shortcut to my Dropbox directory. Because what I used to do is when I worked, I wanted to have the same aliases available on my home computer as I did on my work computer. And so I would source the same file in both of those. And we'll look at aliases here in a minute. I also want to reconfigure my terminal. So these are some control sequences. This is where I got this from because I don't necessarily know these sequences and what \U and \H mean. So I found these, and you can see I've commented out different versions I've tried over time. But if you look, you can see what I have here. If I type pwd, this is my true path. And if I didn't change my prompt, that's what this is called, the prompt, if I didn't change it to only show the last directory in my path, then this would be what I would see every time. And so everything I type would be down here. And because many things I type would be too long for this, they get wrapped around to the next line, and it's hard to follow what I'm doing. So you can see what it does is it trims down what's shown here to the last directory and also puts it up in the title. So if I go to my home directory, you know, it shows home there, shows it here, and that's probably redundant, but CD, this will take me back to that directory. So I've trimmed it down so I have some idea of where I'm at. I want to at least see this, but I don't need to see the whole thing because if I, for some reason, need to, like I said, I can say print working directory and see it there. So I'm using that. Here I'm adding more things to my path. Here's some functions I found online. Let's see what happens here. Oops, I shouldn't have done that. Quit. So let's say I do this. I do cd drop online teaching, and then this directory right here. And maybe I want to work in that same directory over here. Well, I don't necessarily want to type all this again. So now what I type is I, and it just changed that directory. And let's go back to where I was at before, or actually type online. If I want to look on bash RC again, I have, well, you see these are functions. So what happens is when I change directory, it executes one of these functions that saves the current directory into this dot file in my home directory. And then when I type I, like I did over here, it then CDs to that directory, okay, and shows me what it did. So that's real handy. And you can see here's the prompt. And UMask will set the, if I type ls-l, you can see many of the files here have the permissions that they're readable and writable. And that's what this is doing. And then I have some other stuff. I don't even remember what this was anymore. Some of this I probably can take out because it's not even relevant anymore. But this shows you how you can configure your environment to make your life easier. All these things can be typed at the command line, but why would I want to do that every single time I log in? We're going to talk about aliases. So maybe I go to this directory a lot. The bin directory that's in my Dropbox file. Okay? So I just want to be able to type bin and get there. So if I look at my aliases file, and actually it's common aliases here. Let's go to config. That's also in my aliases file. You can see a lot of these are navigational in nature, but other things like when I want to compile a C program and I want to force CCC to treat it as the C89 standard, then I just type C89 instead of typing GCC space dash ANSI dash pedantic. I type log a lot. It turns on syntax highlighting and human readable formatting and some other things. It sorts it by time in reverse order. So see, these are the newest things, things like that. And so you have lots of these things. Like I said, lots of things are navigational in nature, meaning if I want to change to a certain directory, I just want to be able to type config or whatever. When I open files, I could type open in the name, but I type it so fast lots of times. So I may type something like this, open, oops, over here. I may attempt to type open, and maybe instead of typing open, you know, erase.txt, instead what I typed was opne txt, erase txt. And that's misspelled. So I have 6 different ways that I might misspell it and tell it, oh, we'll really just use open. So this is what I type. Here's what it replaces it with. All right. And other things like that. So you can put in whatever you want in these things. When I used to teach, I would configure this every semester to whatever the current semester's version of a directory was. And I just knew 3380 is what I wanted to go to, and this went to whatever the current directory was. So this is the file that was sourced both at home and at work. So that's that right there. So what's the difference between bash profile and bash RC? When I log into my computer, .bash underscore profile is what's executed. So let's do this on home. Because there's certain things, sorry, it should be this. There's certain things that should be executed once and when you log in. There's other things that should be executed every time you open a terminal window. So let's look at this and let's make a change. So I'm going to create an alias. I can put it pretty much where I want, but let's put it right here. I'm going to say alias peach equals, and in quotes, echo $shell. All right. And I would also caution you, before I explain what's happening here, if you're new to making changes to the configuration files, or you're working on a machine that you don't have system administration privileges on, I would not make a change and then log out. Instead, make a change and log in a second time. Like if you're logging into a remote machine where you only can log in remotely, instead of closing that session, log in a second time and make sure you still can log in. Because if you mess up the file, I don't know if it's possible to make it to where you can't log in, but I know from experience you can make it to where you mess up your environment and it's hard to basically do anything. So test it some other way. But let's see what's happening here. Now let's say I open up another terminal window. So I'm opening up here this terminal or xterm or console, whatever you call it. So I open up this right here. We'll make this bigger. And now I'm going to type peach and see what happens. So notice it doesn't know what happened because this file is only executed when I first log in. So I'm going to close this, and now we don't actually need this. I'm going to take this back out. Now let's open up this right here. And so now I'm going to add an alias. Once again, I can pretty much put it wherever I want. Alias peach equals dot echo this right here. And now I'm opening up a console again. blow that up so you can see it. And now I type peach, and what did it do? It just executed this command, echo shell. And I can type alias peach to see what the alias is. So each time I open up one of these non-login versions of a shell, it's running .bashrc. So things that I want to change each time or be executed just when I open up a new window, I put into this file. Now some people tell you, oh, just put them all in the same file. I think that's a mistake, but you're the one logging into it, so do what you want. I work a lot from the command line. And so I do lots of the same things over and over again. And so I want to make my life easier. So how do I do that? Well, one is I can use the history. So if I type history, we can see a history of the things that I've done recently. And if I want to see how many lines are here, let's do history and then grep, or excuse me, wc-l. This shows you I have 68 lines, but this could be longer. History has a max number of lines, but you can change that. And if you want to override the default for how many lines of history you keep, you would put that in one of your dot files, either .bash profile or .bashrc. Okay? So what can I do knowing this? Well, let's say that I remember that I typed this before, but I don't retype it each time. This shows it was command 109. So what I can do is type, and each of these can have its own history actually. See this? They're not the same. So over here I could type exclamation mark 109, and now I just executed that command again. And notice it gave me an error because this was being typed relative to my home directory. It's not appropriate for relative to where I'm at here. To be correct where I'm here, and I'm going to press Control A to jump to the beginning line, I should use home / this, and it would take me there. And we can see this right here. What if I couldn't remember where I was at, and I remember it was something about linear algebra, so I could type Control R, linear, oh, that's that line I just did. And if it doesn't match, I keep typing until I get the match. And I went to there. So I can go back to where I had been. Let's go back to online. And now I'm going to do Control R, linear. See, it's trying to match online. Now I gave it enough to match that. Before it was ambiguous, so it was just matching something else. And go to there. Something else I do a lot, hopefully you know about tab completion. So if I was at my home directory, I type cd dr tab. Okay, it matches drop. Online tab, other tab. That's how I'm doing that so fast. Something else I do a lot is, let's go up a directory. Let's say I did this. I did ls-d online teaching. Or excuse me, I'm already at online teaching, other. And let's say that now I want to see the contents of that directory, this right here. So instead of retyping this, now I can type cat and then exclamation mark $, and this replaces other videos. And so it's telling me it doesn't like that. So I could do, say log that. And now I just looked at that directory and gave me a long listing because that's an alias that does all these things. And it also includes syntax highlighting, so that's why I see it in colors and stuff like that. So if I just ls-l, we need a different command. This would be, it still has syntax highlighting here, but in some cases it won't have syntax highlighting. So those are the things I use the most. Now let's talk about scripts. So you notice I've typed lots of things, but what if there's always, say, 4 lines of code that I type over and over again? I may wish to save those to a file. And so even though there is technically a programming language, we can look and see here. This is a cheat sheet, and this makes more sense if you already know how to program in Bash script. But there is a guide here, and there's this here. I haven't really looked at these much. This right here shows you a bunch of different things, but what it's showing you real fast is you can create statements. We have loops, conditionals. We have arrays. Hopefully they'll show you here. Another loop. There's a function. Let's see over here. This will actually show us arrays and stuff. Or actually, I went to the wrong one, I guess. Yeah, here's the array type. You can create arrays. Your basic programming elements are present here. It's just the syntax is different. Now, I personally don't want to do a lot of programming in the Bash shell. I'd rather use Python or something like that has more features. But you can do those things, right? But even if you're not going to program, you can still collect things into a file. So I might do something like this. Let's say I want to rename, we'll create some files. So touch, we'll say file 1, file 2, file 3, file 4. And so I just touched these files, noticed that created them, but they have no content. And let's say that I made a mistake. They really shouldn't be named these things. Now I could do this. I could do something like move file 1 to file 28. And that renamed it. But what if I want to do this for 1,000 files? Why don't we do these all by hand? So what I might do is this. So let's say I'm going to create a shell. I'm going to call this erase.sh. And now I'm going to get a listing. ls. So I'm actually calling ls from here. And these will be file star. Oops. So let's do this. Why is that not working? Sorry. We'll change our approach. I'm going to do this. ls file star, and then send it to that file. I didn't like my syntax before. So now I'm going to look at the file. So there's those files. Okay. So I can do this. I'm using Vim. If you haven't seen my Vim videos, or if you don't know how to use Vim, watch something like that to know how to edit this. But I'm going to do this. I'm going to say, okay, on every line, I'm going to capture what I have. And so I'm creating a group here. And so move, create a couple spaces, /1. Note that if these had spaces in the file name, then I would need to enclose these in quotes to use these properly. But now I have these lines, and I can change these to, let's change this to say 20, this is 30, this is 40. We'll make this 99. Okay? Look again. So now I type sh and run that shell script, and it just renamed those files for me. So what it did was it executed every line of that shell script. Now what is sh? Well, if I type which sh, it tells you it's user bin sh, but let's go over there and actually see. So cd to /user /bin, and now I'm going to type ls-l sh. Well, this is showing me it's actually what's called a link. So when I type sh, it actually points to the bash program. So there really is no sh program here. Sh used to be the Bourne shell, but modern versions of Linux or modern Linux distributions actually will point this to something else, I think. At least the ones I've used will point it to bash. I don't know if anybody still uses the old one. Okay, but nonetheless, that's what's happening is I want to run that, and let's go back to, well, I can do this. So notice that screwed something up. So I'm going to type s over here using my function, and now I type I, and it just brought me back to here. So I just rename those files. Now what if instead of writing sh, I can actually make that executable. Here's the program, but notice its permissions are read, write, read, and read. So if I can do this, and at the top, I can do what's called shebang. And we said this was /user bin and echo, or do which bash, user bin bash, /user bin bash. And now I'm going to make it executable. So change mod, this will be 744. Or actually we'll make it 755. Erase. So now it's executable for me, executable for my group, and executable for everybody else. So now I could just do /erase if they weren't changed. Let's go in there and prove that. So let me edit that file because they've all been renamed, so that script doesn't work anymore. And let's change these to back to what they were actually. 1, 2, 3, 4. And this was 0, 99, 0, 0. And I think that's the correct file. So now /erase. And you just execute that for me. So that's the easiest way to use the shell script. But we're not limited to that. In this case, it's basically a glue language. I like to use it to call other commands. But we can do some other things. So let me show you a couple programs that I've actually used. So you can see this is, it's been a long time. So I used to teach programming courses. And so I would want to automate part of the process of checking student code. Okay, so these are comments. Now this is commented out, but what it used to do, if it wasn't commented out, is it's going to check the command line. So let me uncomment it just to show you. Because I would need to pass specific information to my script, like the name of the current homework. Here I've just hard-coded it, but if I didn't want to hard-code it, but I wouldn't always remember what I did. So let's save this, and now I come over to here, and I type compare, and run it, and it says, oh, I didn't type something on the command line. I was supposed to do something like this, like it shows me in this example, but I didn't. So because I failed to give it what it needed, it's checking the number of command line arguments. That's what this is. What it did was it showed me how I should have used it, and then it exited. If I actually gave it the right amount of things, then it would skip past the exit and come down here and do certain things. Okay? And since I don't have everything set up over here to use it correctly, I'm not going to actually do that. So let's assume that I gave it what it needed. And so what is it doing? Well, I would have a list of directories for each student in a file called names.txt. And so what I want to do is I wanted to go into the directory for each student, run their code, or compile their code if possible, execute the code, compare their output to mine, and then run to the next student code. And I save the results in a file. So how does it do that? Well, these are backtick marks. So on your keyboard, this is one of the characters right next to the 1 key in the upper left-hand corner. So what this does is it executes cat names.txt. So if there was a file over here called that, so let's say it was this right here, Linux skills bash. So it would be the equivalent of like this, cat Linux skills bash, execute that, and save each line here to be called. So this is a loop in using the bash shell. So file will be the name of the variable. I can call this whatever I wanted. If I wanted to, I could call this giraffe if I wanted to. But I want to make it something readable, right? So I call it file. And so the first time file would be the first name. So if I had something like this, names.txt, I might have, Bob might be the student's name. And that's what, these would be a directory that can call Bob. And then a directory called Mary. And then a directory called Ralph. And so far, and so much. So file the first time would be Bob. And then what's going to do is it's going to echo this variable. So I have to use the $sign. It would echo Bob, showing me. We'll leave this here so I can see it. So it would display on the screen Bob, so I would know what was happening. Then it would write Bob to this file. Notice there I have two greater than symbols. If I did this, if I did, we could create this in this variable. Let's do file equals. So I'm doing basically what it did. So I could do echo file, and let's use one greater than symbol. You see that right there. But if I do this, let's change this to now Mary. Do this. Notice it overwrote what was already there. That's all it has. Instead, what I want to do is to append to the end. So let's go back now and make it equal to Bob. And I'll make this two equal signs. Now, if the file doesn't exist, it will create it the first time, but then it's going to append to the end. See? So that's why I have two equal signs. So it writes the name of the directory to the file. Then it's going to change into that directory. And then it's going to compile the code that's there, including this library. If it didn't compile, it didn't produce a program called a.out. So if a.out exists, then I want to run it and save the results to studenthomework.txt. But sometimes when I execute the code, it creates a seg fault. And if it did, it created a certain number associated with segmentation faults. And if that happened, I want to write that to the results file. So when I'm looking at results, at the end, I'm going to look at this after I've processed all the files. And I want to look at it and say, oh, this code, when it compiled, or excuse me, when it ran, produced a segmentation fault. So I know the student had an error. And then I'm going to compare my results to the results using diff. And the students were given my results so they can match it exactly. And then I remove their version of a.out. And this is how I do a conditional in Bash. So I start with if and end with fi. Then I'm going to cd ... to move back up a directory. Like if I move in, like if I'm here, if I do cd ... then I move up to the parent directory of online teaching. And then I would echo a blank line to results.txt. Then it would come up here, get the next name. So that might have been Mary. Move into the Mary directory, process her stuff. Then move into the Ralph directory and process her stuff and so forth. So I could run this and it would process all that instead of me having to manually do it. Because I might have 50 students, 60 students, whatever. And then when this is done, I just look at the results file myself. So it made my life a lot easier. Another thing I do is I have my own to-do program. And so I'll kind of show you what this does. So we can see if I go to my home program. So my browser is set up to show my home. So you can see here, these are the things that I need to do within the next 7 days. And this is something that I've already passed the deadline on, so it keeps showing up. Here's my weight. I track my weight. And so these are produced in, these graphs are produced in Python. And then these are the things that I've done today. So are the things I accomplished yesterday. I read a lot. These are the things I'm accomplishing today. And so I know I'm going to read these books, so I will update the pages in these, and I'll work out later today. But how do I produce this web page? Well, this uses what are called frames. And so I run a program, or a bunch of programs actually. So when I type to do, you can see there's the date. Here's the things I need to do. Remember, that was what we had right here. I also can look at things I've completed. And that's everything, just flew by. And I want to get these last couple of things, and then I put these into a web page. So if we look at, if I make a change, like if I said anti, that's also an alias. let's say I come down here and say, we'll change this to this category. Erase me, comma, this is an example. I'm going to save that. And now we'll reprocess it. So I type the shell CP to run these tasks. And now we look at the web page, update this, and there it is right there. Erase me. So how did it build this? So if we look at CP tasks, we can see it's going to change to my bin directory. Then it's going to process this header. So let's look at bin. So cat header 2. It puts this at the top of this file. Then it's going to run Python to process the to-do program. It's going to get the end of it. Okay, it's getting the last, the end of the file. It's going to cut out certain columns of that, and it's going to write it to to-do.html. But notice it's appending to what's already there. This gets it started. Or it's going to use this other version if I need to. Because I can also say to do and say days 10, for example, to get the next 10 days instead. It defaults to day 7. Then it's going to take tail and put that on the end. And notice it's bringing in this plot, right, which saves as a PNG file. That would have been produced down here. So now I'm going to run completed, which you saw I can run it from the command line, but this is going to get the first 80 columns right into this file. Then let's get the header added to this. Then I'm dealing with some blank lines. And then eventually I'm going to call plot wait week, and that's going to produce the plots. And so then if we look at home page, we can see this creates some frames. On the left, I use whatever this HTML file is. On the right is this file, and each of these was built by my programs. So I use that every day, a bunch of times actually, every day. So I'm going to go back into this, delete that, save it. And so it just makes my life easier. So there I've glued some things together. Notice that the other one, online. This does a little bit of programming. I have done some things that are a little more complex than this, but for the most part, I don't do much more than conditionals and loops and gluing things together. But I don't have to do all this. I could type every bit of this actually at the command line. I wouldn't need this part because I'm already at the command line, but I could type this at the command line. So let's see how that would work. So this will be somewhat contrived, but let's say I wanted to display the content of each of these files. Now I could do this. I could say cat ex1, cat ex2, and so forth. But instead, I might want to automate this because maybe I have 20 of these. So I'm going to do this. Let's clear this. For f, remember I can call it whatever I want, file or whatever, but last time I just say f. For f in this pattern, ex star.txt, I want to do this. I want to echo the file name. So that's that. And then I'm going to count how many lines are in the file, for example. Or we said we were going to cat it. So cat the file, and then I'm done. And there's those files. Maybe I want to make it easier to read. So let's go back into this. And then after this line, I'm going to say echo and just put a blank line. And so now, what it did, let's run that again. Here's the name of the file. Here's the contents of the file, blank line. Name of the file, contents of the file, blank line, and so forth. So I can do that from the command line. Now I can do things that are more complex, but the more complex it becomes, more likely is I'll probably just save it to a script. But this is something I also do fairly often for things. And that's in my history too. So if you go to my webpage, Brazil.com, and look at my bash shell examples. You can see some examples of that. Every one of these can be typed at the command line like I just did here, and just do it on the fly. These don't need to be saved as shell scripts, although you could. And you see some of these are a little more complex. But there's some examples you can look at if you're interested in that. But I just touched on this is the tip of the iceberg. There's books devoted to the bash shell and probably other shells. There's books devoted to bash shell examples. So if you want to do some programming with bash shell, you can look at those. But this will get you started, and think about making your life easier. You shouldn't do everything yourself. If you find you do the same thing over and over again, maybe you need to reconfigure your environment. Maybe you need to create a shell script to do it. Maybe you need to create an alias to do something. Start thinking about those things and make your life easier.